Hello everyone, welcome to our next CL tutorial, and in this tutorial we are going to analyze amplifiers. Basically there are three types of amplifiers: inverting, non-inverting and difference amplifiers. And we're going to analyze each type of amplifiers now. First we will kind of analyze the basic formula, basic definition, and then we will analyze one problem. So as you can see, in inverting amplifier, the main point to understand is that in any type of amplifiers, just remember that IN is always zero. So what does it mean? The current that goes to this triangular form, so inside this shape, is always zero. And as you can see, the current across the resistor RS goes to the up, now goes to the right. So by the KCL, we can identify that IS is always equal to what? Is always equal to IF, because as you can see, IS is kind of incoming and RF is also incoming, so the value of these currents are same because no current goes to the right side. So the second thing to understand is that the Vn and the voltage here, Vn, okay, let me delete it. Vn here, okay, is same with the voltage, potential, here, Vp. So here Vs, okay, it's not visible, okay, let me draw it here. So here Vrs, let's say, and here we have what? Vp, okay. This Vp is the value of Vp is the same as the value of Vn, this node, okay. So just remember that Vp is always same to Vn, and in inverting amplifiers we have the case that Vn and Vp are always set to the zero. So they are what? They are set to the zero, okay. So now we're going to see the example, and as you can see that there is no voltage source in this branch, okay. In this branch, as you can see, there's no voltage source here, and that means Vn is zero, and also the voltage potential here, just at the end of the Rs, right, is also zero, okay. So let me tell you that the very first step is identify Vn. So Vn in this case is zero, okay. And the second step is to find out the Is. Is is a current that goes across the Rs, resistor S, and in this case Rs is 1 kilo ohm. So the second step, okay, is identify Is. So what's the value of Is? Is is kind of a flow of a current from the high potential to the low potential, right? So in this case, high potential is Vs and the low potential is zero, because, zero voltage, because we know that the low potential equals to here, at the end, it goes from Vs to the low potential. In this case, it's Vn, and we know that in inverting amplifiers, Vn is always zero because there's no, as you can see, voltage source across this branch, which is the value of Vp. So Vn, Vp is equal, and they are set to zero. So we can conclude that Is is equal to what? Vs minus Vn over Rs. So in this case, what we do is that Vs is just Vs, Vn is zero, right? So what we do is just 1 kilo ohm. So the second step is to find out Fs. Not Fs, just Vf, okay? In this case, Rf, the resistor Rf is what? Is 12 kilo ohm, and we want to find out Vf. So if you remember, just a minute ago, I've told you that the If, the current that flows across the resistor Rf is the same with the current that goes across the Rs, okay? In this case, the current that goes across the Rs, so through the Rs, in this case 1 kilo ohm, is Is, and we have found that Is value is just Vs over 1 kilo ohm, and that means the current that goes or flows across through the 12 ohm resistor, kilo ohm resistor, is also Is and is also Vs over 1 kilo ohm. So let me write it. So Vf equals to what? Vf equals to Is and multiplied Rf, right? So I can write that Vf is equal to Vs over 1, okay, multiplied 12, okay. So we can find out that 1 kilo ohm and 12 kilo ohms, they can be cancelled, and what we have is just 12 Vs. So hopefully it's pretty understandable for you. And as I've told you just a couple minutes ago, once you have value of Vf, what you do is just to find out V0, because our ultimate goal is to find out V0, right? So what we do, we just do KVL, apply a KVL in the right part of the amplifier. So the right part is what? As you can see, there's plus minus, and say that it's a V0, right? And the current that goes from here to the plus, okay? And what this current met during this traversal. As you can see, there's no voltage source across this branch, okay? Across this branch, there's no voltage source, so V0. And once it meets here, what? Plus, minus, Vf, okay? You put always plus, minus, because it's a normal definition or normal setup of the polarity, because you put plus and minus while solving. And as you know, when the voltage or current enters the polarity plus, we write just the voltage value is plus, and when it enters minus, we write just minus, okay? So overall, let me write it here. We have what? Vf, right? Vf, and it enters plus polarity. So then it's what? So then it comes here, and the current enters the polarity of V0 with a plus polarity and also plus V0. So let me write it here, Vs. So overall, it's going to be 0, right? And overall, what we have is Vs is equal to, actually, let me delete this one. I mean, it's pretty understandable. Vf plus Vs equals 0, okay? And actually, it's not Vs, but it's, okay, sorry for inconvenience, Vf plus V0, right? Because we are considering only the right part, and in the right part, we have only Vf and V0. Vs is omitted because we are ignoring the left side. So this equals to, this equals to 0, and what we have is just Vs equal to minus Vf, and overall okay, again Vs, I'm writing Vs, excuse me, V0 is equal to minus Vf, and the value of Vf, we know it was minus 12 Vs, okay? So let me kind of repeat you the steps. Firstly, you find out Vn. Vn is always 0 for inverting amplifiers, and after that you find Is. Is is the current that goes across Rs, in this case is a 1 ohm resistor, and then you find Vf. Vf, the current is the same as the current that goes across the resistor 1 ohm kilo ohm, so it's Is, so you just multiply Is, the value that you found one step before, to the 12 kilo ohm Rf, and then you apply KVL and you find the value of V0. So now let's consider non-inverting amplifiers, and as you can see, in non-inverting amplifiers we have in this branch voltage source, and in this case it is Vg. So what we can tell is that now our Vn is not there because we have a voltage source, right? And at the top of this voltage source, this is the value of Vn, so it equals to Vg, right? Because you see there is a ground, right? And when you go to the up, there is a voltage source, and you go here, this is a value of Vn, right? So now in the middle we have a voltage source, and the value of voltage source is Vg. So overall what we get is that Vn's value is Vg. So let me write here, Vn is equal Vp, and it equals to Vg, okay? So it's a pretty simple, And then you can finally find out IS and just repeat the steps that were told just in the case of inverter amplifiers. And now I'm going to show you a problem. As you can see here, in this case we have VA, in this case we have RS value is 25 kilo ohm, and now in this branch there is VB. In this case, that means that there is a ground, and we go to the up, we meet the voltage source, and we are here. Here we find out the value of Vn. In the previous example, we haven't met any kind of voltage source, that's why Vn's value was 0. But in this case, there is a voltage source and its value is VB. So overall, the value of Vn is VB. So what I can write is that Vn's value is the same as VB, and this is the same as VB, okay? The very first step is done. So the second step is to find out IS. IS is the current that goes across the RS resistor. In this case, RS resistor is 25 kilo ohm, and our IS is I25. So let's find I25. We know that the current goes from the high potential to low potential. In this case, high potential is VA. It goes from VA to VP, and the value of VP, as you know, is VB, okay? So VA, okay, VB, right? I've written a little bit above, so no problem. And this is over 25 kilo ohm, okay? So no problem, right? So let me write it a little bit beautifully here. 25 equals to VA minus VB over 25 kilo ohm. So I hope it's pretty understandable for you right now. So the second step is the third step, right? I mean, we have found VP, we have found IS, and our next step is to find out VF, voltage across resistor RF. In this case, RF is 100 kilo ohm. So as we know that no current goes to the right side, yeah? I mean, I25 comes to the node, and all of the current goes to the up because the current that goes to the right is 0, because we have internal resistance, infinite internal resistance inside this triangle. So that means no current comes there. So all of the current goes to the up, and from this point we can just make a conclusion that the current across the 100 kilo ohm resistor, I'm repeating this 100 times, is the same as the IS. So the value of Vs is equal to Is multiplied Rf. So we can find out it, right? So Vf is equal to what? It was Va minus Vb. It's a value of Is, right? 25 kilo ohm, and this is multiplied to 100 kilo ohm. So from this we can find that, I mean, 25 and 100 are cancelled. So overall what we have is just Vf equals to 4 multiplied Va minus Vb. So let me clean the screen for the rest of the solution. So Vf is equal to 4 multiplied Va minus Vb. So I hope it's pretty understandable for you till this part of the solution. So what's left is just to do KVL. So in this case, we consider only the right part. Here we have voltage source, and then we have there's resistor, right, 100 kilo ohm, and then there is what? Overall, we have this. There is V0, okay, and here we have VB, right? I mean VB. So above we have what? Above here we have VF, okay? The polarity is plus minus. So if we traverse from V0, what we met, I mean, V0 is just from minus. If we go to the right, this side, I mean, that's kind of clockwise direction, right? So we met VB, and we're entering to the minus polarity of VB, right? So let me clean the screen. I hope it's pretty understandable for you, right? You can see you can just follow me from this picture. If we go from V0 and from minus polarity to the plus polarity, we meet VB, and we enter to the minus polarity VB. So as you know, if we went to the minus polarity, we write minus VB, and then we write what? plus VF, because what we do is here we have VF, and I've told you that you put the polarity plus minus. It's not visible for you, right? I mean, okay, we write VF and we put plus minus, so we are entering the plus polarity, and the value is VF. So overall, this this equals to what? Plus V0. So what we have is V0 plus VF minus VB, okay, equals to 0. So what we can find is V0 is equal to what? VB minus VF. And the value of VF, we know from the previous step, VF's value was what? 4 multiplied VA minus VB. So you can substitute the value of VF with this expression, and finally you can get V0 equals to VB minus 4VA and plus 4VB. So overall, the simple mass V0 equals to 5VB minus 4VA. So I hope it's pretty understandable for you. So let me clean the screen now and follow up all the steps from the beginning to the final solution. So what we did, the algorithm is pretty same, let's say. So we find V, and in this case, this is VB, okay? And then we thought I25IS. This is kind of the minus of high and low potential. High potential is VA, and the low potential is VN. Actually, VP, which equals to VN, and VN equals to VB. So we found IS with the value of VA minus VB over 25 kilo ohms. And I've told you that the current, I mean, I25 in this case goes to the up because the current entering this triangle is 0. So that means that in order to find out VF, we just multiply IS to 100 kilo ohm, and after that you have VB, and above you have what? VF, so you have V0. So in order to find out the value of V0, once you have the value of VB and VF, you just do KVL, and if you enter the minus polarity, you write the minus, and if you enter the plus polarity, you just write the plus. So it's pretty straightforward. And finally, let's see the difference amplifier circuit. And as you can see here, this is a little bit different, and here we have not only one resistor, I mean not only V2 and R1, but also have R2. In this case, the value of Vn is not V2, okay? I mean, it's not the value of the voltage source that you met when you go from the ground to the up, okay? Here in this case it's a V2, but in this case the value of V and is not V2 because we have not only R1 but also R2. So as you know, let me clean the screen. So in this case, as you know, consider this dot. I mean, the potential at these dots, I mean red dots, are same because the very first dot between the R1 and R2 resistor is Vn, and then the node that's kind of pointed with node A is what? Vp. So Vp is equals to Vn. So how we can find Vn? So in order to find out Vn, in this case Vn is at the node B, okay? As you can see, at the node B we have Vn. So how we can find Vn? So you have to consider this part separately, this part of circuit separately. So what I mean is that you have to redraw this part, actually, yeah. And the value of Vn is voltage source, I mean potential here, okay? Actually, it's not, at the potential here. So in order to find out, okay, let me, so, okay, so what we can do is that Vn's value is the equals, let's say, to the value of the voltage across R2, okay? As you can see, we have R2, right? And at R2 we have a voltage, right? I mean, there is a kind of voltage rise or voltage down, so the Vn's value is pretty similar, pretty same as the voltage across R2 resistor. And we know the formula Vn's, I mean, in order to find out the value of the voltage across any kind of resistor, what we do is we divide the main voltage source to the sum of the existing resistors, in this case R1 and R2, and then we kind of multiply it to the resistors which or whose voltage source we want to find. Okay, I'm going to show you right now the problem, and now everything will be understandable. In this circuit we have what? Actually this is plus and minus VB, and what we have is 1 kilo ohm and then 24 kilo ohm, right? And what we have, our Vn is here, okay? So in order to find Vn, we find the voltage across the 24 kilo ohm resistor, okay? As you know, okay, in this separate circuit, what we have, the main source, this here is a Vs, or yeah, it's VB, okay, Vs, VB, okay, let's say Vs equals to VB. So Vs is a main source, right? Main source. And the two resistors are R1 and R2. In this case, R1 is what? 1 kilo ohm, and R2 is 24 kilo ohm. So how you find Vn? So in order to find Vn, first we have to identify which or let's say whose whose resistor does this Vn corresponds. Okay, so Vn, as we know, is a voltage source or voltage down or drop across the 24 kilo ohm resistor. So that means that VAV, our main source, over R1 and R2 multiplied to R2. Okay, I'm gonna write everything a little bit clear now. So our Vn is equal to VB over R1 plus R2 multiplied to R2, because this is from definition, okay? So R2 is 24, so let's find Vn. Vn is equal to VB over 25 kilo ohm multiplied 24 kilo ohm. So now we can conclude that Vn is equal 0.96 kilo ohm, but there is also kind of, sorry, it's not kilo ohm. Vn is equal, sorry, it's equals to 0.96 VB, okay? So the very first step is done, so let's clear now the window. So the very first step is done, our Vn, Vp is equal to 0.96 VB. So second step, as we know, is to find out Is, okay? So Is value in this case is what? Is value is from Va to Vp over 1 kilo ohm, right? As you can see, 1 kilo ohm is the value of Rs. So we can conclude that Is value is Va minus 0.96 Vb over 1 kilo ohm. So it's a pretty simple, right? So the second step is done. The third step is to identify the value of Vf. So Rf is 25 kilo ohm, and as you know, the current across this Rf resistor is the same as the current that goes across or through the 1 kilo ohm. That means the current Is flows across 1 kilo ohm and also flows across 25 kilo ohm. That means in order to find out the value of the voltage across this resistor, you can just use the Ohm's law and just multiply Is to this 25 kilo ohm. So the value of Vf equals to Is multiplied 25 kilo ohm. So once Vf is found, okay, let's write the expression of Vf. We know that Is equals to this Va minus 0.96 Vb over 1 kilo ohm. So our objective is now to write the value or expression for Vf is what? Okay, just 25, right? Multiplied Va minus 0.96 Vb, brackets are closed. So just remember this expression. So now we have to apply KVL. So we know VF, we know VP, and our objective is to find out V0, right? We consider the right part. I'm going to draw the right part. I mean, the right part is what? Plus minus V0, and it goes from here. It meets what? Resistor 24 kilo ohm. And we know that, and we have to put the signs like plus and minus, right? And we know that it enters minus polarity, and we write minus V P, right? VP, okay? Minus, we write minus VP, and then it meets, because you know it enters polarity minus here, right? If it enters polarity minus, we write minus VP. So after that, it goes up and meets plus minus VF, okay? The polarity is plus, so that's why you write here plus VF, and then you meet plus V0, okay? So overall, we can write that V0 is equal to VP minus VF, and you can substitute the value of VF here, and find out that V0 is equal to VP plus actually 25, right? 25 VA minus 0.96 VB, and the rest of stuff is pretty easy. I mean, you just substitute the value of VP with 0.96, and then you can find the final expression. And overall, I'm going to write the final answer. You're going to have V0 is equal to V0 VA multiplied 25 minus 24.96 VB. This should be your final answer. So overall, let me write the final formula, the steps in order to analyze amplifiers. Firstly, you just find Vn and Vp, okay? In inverting amplifiers, it's 0. In non-inverting amplifiers, it equals the voltage source that's in the branch. In difference amplifier, you just use a formula, okay? V over R1 plus R2 multiplied R2. So secondly, let's write that we have to find IS, and IS formula is VA is going to be given VP and over RS. VA's value, RS value are going to be given, and you use VP's value just from the step before. And the third case is what? To find out VF, and VF is equal to IS multiplied RF, right? So you just, in order to find out VF, you're given the value of RF, you just substitute the value of IC from the second step, and then finally you do what? KVL. Use KVL, and please do not forget that if you enter plus, you're going to write minus voltage source value. If you enter minus polarity, you write, plus. If you enter plus polarity, you write plus voltage value, and if you enter minus, you write minus voltage value. So this is the algorithm, this is the steps. I hope it was pretty understandable for you. Just stay tuned, and in the video description you're going to be shared all the solutions. I explained you the purpose of this video, not to just show you solution, just to explain you the technique and have identified technique. So in the video description you can find all the formulas, supplementary materials, and together briefly explain the solutions. So don't worry, solutions are shared. Thank you, and see you soon in our next tutorials.